This is the fourth video of a series on vectors. The first three videos covered vectors in 2 dimensions. This video extends to 3 dimensions, first looking at 3-dimensional coordinates. Very difficult to depict points plotted in 3 dimensions on 2-dimensional surfaces. Here I have 3 axes. The x-axis is horizontal, the y-axis is into the board here, and the z-axis is on the vertical. Only dealing at the moment with positives. So this is to depict the point 3, 2, 4. That's 3 along in the x direction, 3 horizontally, 2 into the board. That's at right angles to the x-axis here, and 4 units in the vertical. So these 3 axes are at right angles to each other. So 3 units on the horizontal, and there's a right angle here as you move into the board, and then a right angle here as you move vertically. So that's the point 3, 2, 4, x coordinate 3, y coordinate 2, z coordinate 4. So 3 mutually perpendicular axes, x, y and z. That's the set of axes we're going to be using. Then we're going to introduce negative direction after that. So here's a cuboid. Its length is 6 units. Its breadth here you can see is 2 units. And its height is 5 units. So that point here marked P is therefore x coordinate 6, y coordinate 2, that's 2 into the board, and 5 units vertically. The coordinates are in brackets here, 6, 2, 5, x, y and z. Here's another cuboid. Its length is 5 units. Its breadth here is 4 units. And its height is here at 3 units. So on the x-axis it's 5 units along. On the y-axis it's 4 units into the board. And on the vertical it's 3 units vertically to get to Q. So Q is the point 5, 4, 3. X, Y, Z. x5, y4, z3. So this cuboid has length 2 units here, width 1 unit, and the height is 6 units. So point R here is x coordinate 2, y coordinate into the board 1, and vertically the z coordinate 6. So that's the point 2, 1, 6. This cuboid length is 4 units, the width is 2 units, and the height is 5 units. So for point S, it's x coordinate 4, y coordinate 2, z coordinate 5. So that's 4, 2, 5, x, y, z. Here's the point T. The cuboid is 3 units along here at the x-axis, 4 units in to the board on the y-axis, and vertically 4 on the z-axis. So that point T is 3, 4, 4. So for this point U, 6 units along the x direction, 5 units in the y direction, that 5 there, and then height, the z direction, 2 units. So it's 6 in the x, 5 in the y, and then 2 in the z. So that's 6, 5, 2. So kind of question, it'll be in a worksheet, which if you click the link in the description, is there as a PDF and it's got answers with it. So it's this kind of question. There's a cuboid, its length is 4 units, its breadth is 3 units, and its height is 6 units. You have to give the coordinates of the various points. So the origin's obviously 0, 0, 0, x, y, z, all 0. To get to A, you go 4 units along the x direction, but 0 units in the y direction and 0 units on the z direction, which is why it's 4, 0, 0. For the point B, it's 4 units on the x, 3 units on the y, and 0 units on the z. so it's 430. And for point C, you're 0 units on the X, 3 units on the Y, and 0 units on the Z. So there's C at 0, 3, 0. And you do the same for D, E, F. So for D, you're 0 on the X direction, 0 on the Y direction, and 6 on the Z direction. So it's 0, 0, 6. In E, you're 4 on the X, 0 on the Y, and then 6 for the Z. So that was 4 along, 0 in, and 6 up. So that's 406. And for F, 4 on the X, 3 on the Y, and 6 on the Z, 436. And for G, 0 on the X direction, 3 in the Y direction, and 6 in the Z direction, 036. Now, that cuboid's showing this is the X direction, this is the Y direction in the way, and the Z direction's on the vertical. These axes could be rotated. That's the very same diagram, just the X direction's over here, the Y direction's there, the Z direction's up the way. These three axes are at right angles to each other. It's the same set of answers, so it's just the axes are slightly orientated differently. And this one, it's telling you the point F here is 348. It's telling you the cuboid's got the same sides as before, 436. So it's lifted away from the XY plane. So it's been lifted up, but it's very hard to show in 3 dimensions on a diagram. So based on 348, we can work out the missing coordinates. So for example, if we wanted a B, it's 6 units below F, it's 6 less on the Z coordinate. So B would be the same X and Y coordinate, but the Z coordinate's 6 lower. So that's why it's 342 instead of 348. The Z coordinate is 6 less because of this 6. There's B at 342. So 3 in from that is point A, but that's 3 in on the Y axis here, the Y coordinate. So it's actually reducing the Y coordinate by 3. So this is 342. This is taking 3 off the Y coordinate, so it's 312. The Y coordinate lost 3. Here, this is 4 on the horizontal here, parallel to the X axis. So going from A to D, that would be taking 4 off the X coordinate. So this is X coordinate 3 and it loses 4. So therefore you take 4 off the X coordinate. So this 3 went to -1. It was the same Y and Z coordinates. So that's -1, 1, 2. For C, it's, if you look at -1, 1, 2 for D, this shifts it 3 in the Y direction here to get to C, this 3. So you give an extra 3 to the Y coordinate. That's what makes C -1, 4, 2. The Y coordinate of D gained 3. Now you can do the same with all the various points. Simply, for example, comparing F and G. From F to G, that is 4 units long in the X direction. So you take 4 off the X coordinate of F. This 3 goes down to -1. The other coordinates stayed the same, the 4 and the 8. If you look at E, it's from F to E, the Y coordinate is going to lose 3. That's 3 units here for that side. So this is 3 in the Y direction. So you take F and you subtract 3 from the Y coordinate. That's why it's 318. And if you look at G and H, you can take G and that's 3 off the Y coordinate for this side. So you take G and take 3 off the Y coordinate. You get -1, 1, 8, 3 off the Y coordinate. So you'll notice, for example, D and C and G and H, they all have the same X coordinate. And EF and A and B, they all have the same x coordinate. In the y direction, that's in the way to the board, the F and the G and the C and the B all have the same y coordinate because they're the same amount into the board. And at the top, E, F, G and H all have the same z coordinate because they're all 8 units up. And the same A, B, C and D are all the same z coordinate because they're all 2 units up. So it's all from starting at point 348. You can work out other points, and then from these other points work out points near them and gradually work your way around the whole cuboid. Here's an easier case. This is a square base pyramid. That's the point 600, so this is obviously 6 units long. So therefore AB here is 6 units long because it's a square in the bottom. So if you want B, it's 6 on the X and then 6 on the Y and 0 on the Z. 660. If you want C, it's 0 on the X and it's 6 on the Y and it's 0 on the Z. So 0 for the X, 6 for the Y and 0 for the Z. Hence it's 060. And finally D is going to be right in the very middle of this square, right above it. It says the height of the pyramid is 8 units. So D has a Z coordinate 8, but it's halfway along OA, 3 units along, and then it's halfway in, half of AB, and then it's straight up. So it's actually 3 in on the X, 3 in on the Y, and then 8 units up. Hence it's 338. Now, that was using positive x, y and z coordinates. Now to try and depict negative x, y and z coordinates, that's quite difficult on a flat surface. So this is an attempt to show into the negatives. This is a 4, 2, 6. So that means 4 on the x, 4 along the x axis, 2 along the y axis, that's 2 in the way, and then 6 up. So as best you can depict it, here it is, 4 along, and at right angles to that, 2 in the way, and at right angles to that, 6 vertically. That's the point 4, 2, 6 for the x, y and z coordinates. That's point A. So here's 4, 2, negative 6, as best you can depict it. That's 4 along on the x, 2 in on the y, and then 6 down on the z. Here's 4, negative 2, negative 6. So that's 4 on the x, negative 2 on the y, and negative 6 on the z. So here we're going 4 along the x. This is coming 2 out of the board, as it were, 2 out the way for negative 2, and then 6 down the way for the negative 6. So x, y and z axes are at right angles to each other, and it's difficult to picture on a flat surface, a two-dimensional surface. Here's negative 4, negative 2, negative 6. So that's negative 4 on the x, out the way for the negative 2 on the y, and then 6 vertically. And here's negative 4, negative 2, negative 6. So that's negative 4 on the x, negative 2 on the y, so that's 2 coming out the board, as it were, and 6 down the way. And after this will be 3-dimensional vectors, but that's 3-dimensional coordinates, so the next video will be 3-dimensional vectors. If you click the link in the description, there's a worksheet on 3-dimensional coordinates, and it also has 3-dimensional vectors on it. There are 4 examples to practice on for coordinates in 3 dimensions. Just stuck to the positives because it's very hard to depict the negatives, and it's got the answers with it at the end. There's a set of notes using the same link in the description, covers all the videos and vectors. first video, second video and third video were all 2 dimensions. This is 3-dimensional coordinates, and it will move into 3-dimensional vectors in the next video. Hope you found this video useful.